So Elegant Embellishments are architects. We're a team of manufacturers. We're based in Berlin. And we tend to research climatic issues that have the potential to be realized in building products, and mainly in facades. And we like to say we make the link between architecture and the atmosphere. So this is Beijing. And you'll notice the first thing that you see in this photo is not the city itself, but the air in the city. Air pollution in Beijing is a huge problem. It affects daily life. It's an architectural condition, and yet the architecture is making no reference to it. So air pollution is composed of several things. It's composed mainly of NOx, VOCs, SO2, fine particulate matter. And this is a technology that fights air pollution. It actually uses only sunlight to convert NOx into harmless substances. It was developed as a commercial paint. It's a white paint. It's a smart material, but it's actually formless as a paint. There's a link in the biological world between light and complex surfaces. And in the case of corals, they need surface enlargement in order to grow, in order to photosynthesize. And so we wondered if we couldn't develop a substrate for this light-activated technology that could use surface enlargement to increase its efficacy. And this is ProSolve. This is a product that we developed and manufacture. It reduces air pollution in cities. And with ProSolve, we're able to cluster the titanium dioxide technology onto facades, which are the natural receivers of pollution from cars. So in 2012, we put ProSolve on a building. Oh, one back. There you go. And this is a hospital in Mexico City. This is the Torre de Especialidades. And this hospital facade is currently reducing the pollution of about 1,000 cars on the road in Mexico City per day. It's the world's largest urban air purifier. So I've realized in the last year that we have a lot of things in common with Mars. And one of them is that we have a scarcity in resources in an increasingly hostile environment. And if you imagine Matt Damon here sitting on our own planet in 50 years, what technologies can harness our atmospheres for new resources? There are many technologies doing just that. These are two. One of them here, New Light Technologies, they're actually converting methane emissions directly into commercial plastics. So they're synthesizing a material from air. According to COP21 last year, we're in danger for global warming. They set a target of 1.5 degrees Celsius to lower global warming. And it's been confirmed that in order to reach this target, we can't just keep going with carbon neutral processes. What we need are carbon negative processes. And this means that we need processes that are going to reduce more CO2 than they create. So we have our carbon positive past, which is our problem. We have our carbon neutral now, which we're aiming for. But what we need is carbon negative. And that means we need processes that will draw carbon down from the atmosphere and sequester it. And one of these processes is called biochar. Biochar is the burning of any biomass into a stable form of carbon char. And what happens is when a plant absorbs CO2 in its lifetime, when the plant dies, it releases the CO2 back into the atmosphere. With biochar, we're actually sequestering the CO2 into a carbon char. And this is a material we're proposing that will convert greenhouse gases into a building material. And it's 50% atmospheric carbon. And so when we scale that up, we get 1,000 kilograms of CO2 sequestered per ton. And in the construction industry, which is our largest material producing industry, we're actually talking about sequestering gigatons of CO2 with this material. So as architects, we're interested in finding form for this material. We call it made from air. And this is a facade panel we've developed that's called HexChar. And this is a hexagonal panel. These are scaled prototypes. And they are reversible. They're lightweight, they're robust, they're compression molded, they have great fire properties. We're just beginning to find new applications for it. We're currently in a testing period for facades. So at 1,000 square meters, to give you an idea of this material, we're sequestering about 10 tons of CO2. And this is a significant thing because we're now talking about a material that in its process is having effect. It's not active the way that ProSolve is on a building, but it's already finished its kind of effect. And what it's doing by putting it on a building, by putting a carbon negative module on a building is sequestering carbon onto a facade, which means that we're actually turning building into an environmental act. So here you can see some new research. We're using structural wall, a module we're developing for a structural wall. We're also looking at acoustic research. And this brings me to the new metrics of building, which are energy positive and carbon negative. In that what we want now are buildings that can produce more energy than they use and can reduce more carbon than, reduce more CO2 than they produce. And if we get these two processes right, the best thing we can do is build. Thank you.